Hey everyone, how goes it? And welcome back to Computer Science 146. Today, we're going to go over even more programming review with a big example. Here's the problem that we are going to address. I like to travel around, and while I travel, I like to eat tacos, one of the world's most perfect foods. Now, the problem is I want to keep track of all of those tacos that I've eaten. And I want to keep track of information about them, like the name of the taco, the location that I found it, and also the price of the taco. Now, the purpose of what we are doing is we are creating solutions to these problems. There are a number of problem-solving solution strategies. One of those models that was used early on in computing was called the waterfall model. Now, this model is really good for very small projects. But when projects get larger and larger, then we may want to consider other types of models. But once again, if it's a small enough problem, this model is fine to solve a lot of problems. Now, the waterfall model has some essential elements. First is the requirements. This is where we gather the information and figure out what we need to know in order to solve this problem. Solving problems is always mapping the knowns to your unknowns, so gathering your requirements is essential. Once we know what we're going to make, we move on to the design phase. This is where we start mapping out how we're going to then implement the software. Next, we implement the software based on the design. After we have created the solution, we have to verify it by running it through a series of tests. Now, once we've tested the software, we have to continue to maintain the software. Adding new features, modifying features, fixing bugs, we have to maintain what we have created. We're going to focus on the first three parts of this. We're going to establish what our requirements are, design the software, and then go through implementing the software. So we need to figure out what is required in this solution. We understand from the problem that we need to keep track of important taco information. But what information do we need to keep track of? Ideally, I would like to keep track of the taco's name, their location, and their price. Now, this is an entire collection of these tacos. So when I'm thinking about functionality that this software should have, I should be able to add tacos to this collection. I should be able to remove tacos by their name. I should sort them, and I'm just going to say, let's sort them by price. It should be able to display all of the taco information that's held in the collection. We should also be able to store this information in a taco file that can be read whenever we run this software. Now finally, we need a clear and simple front end to use this software. So this is what we require: collecting taco information, being able to add, remove, sort, display, store, and read from taco files, and a clear and simple front end. Now we move on to the design phase. There is a lot of techniques and diagrams that is used in designing software. Before we go into those, let me mention one design technique that I strongly advise is to always separate front-end functionality from your back-end functionality. The front end for software is what the user uses to interface, to use the elements that are developed in the back end. The back end is usually all of the functionality that makes the software work. Now, moving on from separating front end and back end, we can start modeling the software by using what's called a UML class diagram, Unified Markup Language Class Diagram. A UML class diagram is used to represent classes that are used in the software and the relationships between those structures. Boxes in a UML class diagram indicate classes, and the arrows in a UML class diagram represent the relationships between these structures. Now, as we can see to the side here, this is an example of a UML class diagram, and as you can see, this is separated into three sections. The first section is the class identifier, the name of the class. The next section are the properties. So this would contain the instance variables, constants, and anything that is a property of an instance of this class. Finally, the last section are the methods. This indicates the actions in which this object can perform. As a note that we'll get to later on, we use the plus and minus to indicate the scope of these different properties or methods. So the plus indicates that it would be public, and the minus indicates that it would be private. The arrows in a UML class diagram indicate the relationship between these classes. Now there's different kinds of arrows, but the two that we're going to focus on is the association, which is the has a relationship, and also the inheritance, the is a relationship. So the way that you can think about this is this class has instances of that class. The other version, this class is a more specific instance of that class. This is inheritance. In other words, in Java, extends. Let's apply this to the solution. We are maintaining a collection of tacos. So this is where I've been mentioning, keep track of those nouns and those verbs. The taco is an obvious noun. And so what we need to do is create this class. That way we can create instances of these tacos. The information that we need to contain for every one of the tacos was its name, its location, and its price. As a reminder, the minus sign indicates that this is a private scope. Instance variables should be private, that way we adhere to encapsulation. Now the way that you would read this, it would be written private, string, name, private, string, location, private, double, price. Now in the next section, we write the different methods that this class is going to have. Also, as a reminder, the plus indicates that the scope is public. So the way that you would read this would be public void toString, no parameters, and public boolean equals with an instance of a taco. This is one of the classes that we need to develop this software. But this isn't the only thing that we need to do. This is going to hold the information, but we need a lot of functionality. This feels like a different noun because the taco itself just holds the information. What we need to do is manage this collection. So as this feels like a different noun, we're going to create a different class, and I'm going to call this the taco manager. The purpose of the taco manager is to manage the collection of tacos. So first, after we have defined the name of this class, Taco Manager, we have to then worry about what are the properties for this. One of the most obvious ones is this array of tacos. The array of tacos is our collection. Now, there is a lot of other properties here that need to be explained. First of all, as indicated on a previous slide, anything that is underlined indicates that it is static. Also, anything that has all uppercase letters in the identifier is assumed to be constants. So this is a static constant just like this, and just like this. There's a lot of constants built into this taco manager. Now we're going to assume that we're going to create a default and a parameterized constructor for this taco manager. However, we know that we're using an array of tacos. This means that we have to indicate some sort of default size. The default size, I would argue, should be constant because it wouldn't change. From there, we know that we have to write taco files. And what was really important about understanding files was understanding a file's format. Each one of these elements represents something regarding this file format. So what is the file format that we're going to create? For this example, we are going to use a tab delimited file. And its format goes as follows. We have some header information here, which basically gives the amount of tacos that are found in the body. Over here is the body, where we basically have the information, name, location, and price. Notice that each one of these elements here and here are separated by a tab delimited, tab separated file. You can think of the tabs as effectively being a column inside of a spreadsheet. Also, you can see we have end line characters here that separates out each one of the rows. So an example of this file would be, we would have literally the taco amount followed by a tab and then the number of tacos, in this case 3. Then we have the name of the first taco, tab, its location, tab, its price, inline. The next one, name 2, tab, location 2, tab, price. Name 3, tab, location 3, tab, the price 2.5. The delimiter that we're using to separate out these fields, in other words, this part here, and also this part here, here, and here, is always going to be a tab. So this is why the delimiter is assumed to be static and constant. Now the header is separated by one tab, and this indicates that it has 2 fields. This field right here, and then this field here. Similarly, the body has 2 tabs, which indicates that it has 1, 2, 3 fields. Both the header field amount and the body field amount are also constant values, so we just define them as constants. So now we've gone over the properties, we have to address the functionality in this taco manager. What was said in the requirements is we need to be able to add a taco, remove a taco by a name, print the tacos that are currently in the collection, write to a taco file given a name, read a taco file given a name, sort the tacos by their price, and there's one extra method that we included in here, which is called init. This is short for initialization. We'll go over this a little more when we start writing those constructors. So now we have these 2 different classes, taco and taco manager. We need to establish the relationship between the taco manager and the taco. What we have is the association, the has a relationship. And the way that we would read this is our taco manager has 0 to many tacos. And this is indicated by using this array. All of this functionality is used to maintain this collection of tacos. So we would consider all of this to be our back end. However, we need users to be able to use this software, which is why we also need to develop a front end to utilize the functionality in the back end. In this case, we create a taco manager front end, and from there we create static properties, a taco manager and a keyboard. Notice that these aren't all capitalized, so they are not constant, but they are static. From there we have some methods. The main method, printing a greeting, printing some choices, add taco, remove taco, read taco file, and write taco file. Notice that each one of those methods is also static because it's underlined. The reason why we've made everything static inside of the front end is so we can just simply call it from this main method. This only provides the functionality so users can use the actual functionality in the back end. In other words, this add taco method is going to utilize this add taco method here. Now that we have our design, let's go ahead and start implementing our software. Where we should first start out is with one of the most essential elements, the taco itself. So let's go ahead and write this taco class following those 7 easy steps. Step 1, define the class. So now we have this class tacos from which we can create instances or objects of this type. Next step, we need to worry about our properties, our instance variables. Their scope should be private. Private string name, private string location, private double price. Next, we need to write our constructors. Let's start with the default one. Public taco, no parameters. Let's set each one of these to a default value. So we're going to set this dot name is equal to this dot location is equal to none. We're also going to set this dot price is equal to 0. Next, our parameterized constructor. Public, taco, string, a name, string, a location, double, a price. I'm going to put the comment here to do call mutators. Next, we need to create accessors for each one of these properties. Public string get name. Return this dot name. Public string get location. Return this dot location. Public double get price. Return this dot price. Next, we need to create mutators for every one of these. Public void set name, string a name. When it comes to object types, make sure that this is not null. If a name is not null, then we're going to simply assign this dot name to point to a name. And if this is not true, we're going to set this dot name is equal to the default value none. Next, public void set location, string a location. Same rules apply here. If a location is not equal to null, then we assign this dot location is equal to a location. Otherwise, we set this dot location equals to none. Next, public void set price, double a price. Now the only rule that I'm going to set for the price is it should not be a negative value. So if a price is greater than or equal to 0, then we consider it valid. So we'll set this dot price is equal to a price. Yet if that's not true, then we need to set this dot price is equal to 0, some valid default value. Now that we have written our mutators, let's not forget to go back and call them from our parameterized constructor. This dot set name, a name. This dot set location, a location. This dot set price, a price. The purpose of a parameterized constructor is to both construct an instance of an object and set all the properties at the same time. However, if we are setting these properties, we also need to verify if they are correct. This is why it's a good idea to put that error checking only in the mutators. And then from there, if we call the mutators, we know that as long as these are called, the errors are being checked. Now the other useful methods is the toString and dot equals. Public string toString. What we're going to do is return a string with all of the properties concatenated together. Return name plus this dot name plus location plus this dot location plus price plus this dot price. Finally, equals. Public boolean equals taco a taco. Now we're going to return first, a taco cannot be null. If it is, then no, they are not equal. And this dot name. Strings are object types, so we need to use the dot equals method in order to compare a taco dot get name. So if this name and this taco's name are equal, then we consider that equal, but we still have to continue to check. And this dot location dot equals a taco dot get location. And finally, this dot price, this is a primitive type. It's a double. So we use the double equals and a taco dot get price. So now we have developed the class taco, and we're going to use that in our taco manager. Now what we need to do is start developing the taco manager. So let's go ahead and start. First, we're going to go ahead and create a new class, and we're going to name it Taco Manager. Now we understand that we're going to be doing some file I/O. So before we write anything else, we need to include some packages. Import java.util.scanner. That way we can do file input. And also import java.io.star. So we can also do file input along with some other operations. Now we have already defined the class. Let's go ahead and start creating the properties for this. First, the instance variable, private taco array, and we're just going to name it tacos. Next, we need to create some constants. The first one, public static final int default size. And we're going to just assign that to the value 10. We will discuss what this is used for in a little bit. Next, public static final string delimiter. And as described before, our delimiter is the tab. Next, public static final int body field amount. And we're going to set that to 3. And public static final int header field amount, and we're going to set that to 2. These 3 constants are going to be used for file operations, which we'll discuss a little bit later on. Next, let's go ahead and create the constructors. Let's make a default one. Public taco manager, and we're taking in no parameters. The purpose of a default constructor is to both construct the object and also set all the properties to default values. The only property that we need to set to some kind of default value is tacos. Now, tacos is a taco array. What we know about arrays is when we construct them, we need to know their size. Not only that, what this is the collection that we're maintaining with this class. So in fact, I'm going to skip ahead a little bit and start addressing the parameterized constructor. Instead of how I would normally write it, I'm going to write my parameterized constructor like this. Public taco manager int size. The thing is, I want to protect this information because that's what we're maintaining. We're maintaining this collection of tacos. I don't want to give access outside of this taco manager because this is the thing that is adding, removing, sorting, printing, and everything that needs to manage this thing. This means I am not going to allow another programmer to pass in a taco array via parameter because they may not structure this taco array in the way that I was intending. So in order to best safeguard this, I am not allowing access or mutation of this value. The only way that you can modify it is by using certain methods like add and remove that we'll develop later on. However, this still doesn't address the fact that we need to construct this object to something initially. I'm going to do something a little different here too, because I'm going to create another method before I get back to the constructors. This method is going to be called public void init. Init is short for initialization. And what we need to know before we can initialize an array is the int size. Now we need to check if this parameter is valid, and I would argue arrays need to be at least size 1. So if this size parameter is greater than or equal to 1, then we feel safe in creating tacos and then constructing new taco given this size. Now if this wasn't true, we still need to construct this object. And this is where we rely on the default size. That way, if this size was incorrect, at least we can tacos equals new taco with the default size. This also might be a really good place to put an exception. To keep things simple, we're going to skip that for now. Now to finish this off, what we need to do is then initialize init. And since this is the default constructor, we use the default size. And then our parameterized constructor, we pass in this size. And now we can create a taco manager that initializes this array of tacos to some sort of default size or some sort of given size. The next thing that we're going to focus on is adding and removing those elements. But before we get to that, we have to address something. How is this taco array organized? An array is a data structure. However, it's not organized in any particular way. We have to organize the array how we see fit. And keeping data organized, keeping data structured is essential for efficient algorithms. So now what we need to figure out is how we are going to structure this array to make our life a lot easier. In order to address this, we're going to take a look specifically at this taco array. Now, this is an array of an object type. And the way that we can think about this is object types, remember, they are separated based on the reference, the memory address, that references its contents. This means that everything that is held inside of an index of an object array is simply a memory address. Now this is also referenced by the array's identifier. So you have a reference that references a lot of other references. Now also, when you construct an array, Java assumes default values, and the default value for an object is always the memory address null. So when this array is constructed, all of the information, all of the objects are initially set to null. Going into more detail, the name of our identifier, the name of our array is tacos. So when we use that reserved word new and we construct it, and let's say we use the default size, which is 10. So when we use that word new and we construct 10 elements, it looks something like this. And then once again, the identifier tacos references the contents of the array. It points to the first element. Keeping all of this in mind, we can now structure the array. I'm going to take a very straightforward and simple approach that is commonly used for how to structure an array. We're effectively going to keep all of the constructed objects, in other words, the non-null objects, all to one side. So this means starting from one constructed object to the last constructed object, there are no null elements in between. And the first null element encountered indicates that everything after that is also null. Let's take a look at the algorithm for adding an element in this way. First thing you do is start from the first index. So you would start at index 0. From there, what you would do is find the first null element. Well, luckily, index 0 is null. So if we are passing the reference, the memory address that we want to assign to here, we can just assign it at that index 0. So let's assume that it was 86. This taco object is constructed at memory address 86, and now this first element references that object. If we were to add another element to this, simply enough, we find the first null element after starting from the first index. So starting from right here, this is not null, so we have to move to the next element. This is null, and so we assign the memory address, let's just say arbitrarily 283, points to that next constructed object. And if we were going to do this one more time, we're going to add one more element to this array. If we start from index 0, that's not null. If we move to index 1, that is also not null now. Index 2 is null, so we add the next one there. Let's assume that it's constructed at memory address 128. Now keep in mind that everything after this, we can assume these values that are represented here are null. This means tacos at index 3 is null, and everything past that is also null. This keeps all of the constructed objects to one side of the array. Now let's take a look at remove. For argument's sake, let's say that we wanted to remove this from the array. As we know, if we want to remove an object from memory, in Java what we do is we lose the reference. We lose the path to that object. So what we could do is just assign this value, the one that we're trying to remove, to null. Now, as we have lost the memory address that was previously there, Java, being a memory-managed language, has a mechanism called a garbage collector. It would go and deallocate that memory from where that object was because we can no longer access it. We've lost the memory address. But there is a bad problem with this. We cannot do this in this way because it breaks the rule for how we are structuring our data. If we were to assign this value to null right here, we have two constructed objects after it. Well, one of our rules is the first null element means everything after it has to be null. We can't remove an object in this way. So what we're instead going to do is, instead of just saying null, we are going to shift everything in that array over by 1. The way you can think about it is something like this. Every index is assigned to its index plus 1. Thus, when we do this, it shifts the values over 1 at a time. Now this replaced it and became 283. This replaced that, becoming 128. We assumed tacos at index 3 was null, so this got assigned to null, and everything gets shifted over by 1. Now, if you successfully remove an object from this array, it's always a good idea to set that last element to null. That way you don't accidentally have a duplicate element at the end. This is how we are going to structure our array. An array is a foundational data structure. It doesn't assume that it's structured in any way. We have to give it the structure itself. And that is one of the key elements of this class, knowing how to structure data. Let's go back to the code. Knowing that, let's go ahead and start adding these tacos. Public void add taco, a taco. We're going to assume that a taco has already been constructed outside of this. Now, arrays are not resizable in memory. We have to give the size from the beginning. So when we're adding elements to this data structure, we have to recognize that we have a fixed size. So in fact, one of the first things we need to check when we're adding data to an array is whether or not that array is full. In order to do this, as we are structuring our data where all of the constructed objects are on one side of it, we can check whether or not this is full simply by checking the last element. If tacos at index tacos.length -1. Now we know that this is the last valid index. If this value is not null, we need to return because this indicates this array is full. If everything is grouped together on one side and the last element in this array is constructed, that means every other element in this array has also been constructed. It is full. However, if that's not true and we don't immediately jump out of this loop, what we need to do is start from the first index and find the first null element. For int I is equal to 0, I is less than tacos.length I plus plus. Inside of here. If tacos at index I is equal to null, meaning that it is the first null element that we have encountered, then all we need to do is take tacos at index I and assign it to a taco. This is an object type, which means this identifier only holds a memory address. This memory address is then assigned into the array. So this array points to some contents. Now this is one element of the array which now points to where this object is in memory. Once we have that, let's go ahead and break. The reason why we need to do that is because we don't want to add duplicate values. If we forget to do this, we may accidentally add a taco to every element in this array. That's not what we want to do. Now, outside of that for loop, I'm going to go ahead and write a to-do, and I'm going to call sort. This is how we can add elements to this array. This is how we can add the tacos to the taco array. Now, let's go in a little more depth with how this works. Now, backing up just slightly, let's go ahead and establish the initialization step. Whenever we have constructed a new taco manager, we know it's going to call the method initialization. For this example, let's assume that the size was 4. So if we start right there, we know that the size is greater than or equal to 1, which means we can now construct this array of tacos. This taco array is going to be of size 4. So that memory is then allocated right here. Now, once the memory has been allocated, we have to assign the memory address to the identifier tacos. So in fact, you can think of the identifier pointing to the first element right there. Now, we're going to add tacos to this array. If we once again assumed that the parameter a taco had been constructed outside of this, this indicates that this identifier has been assigned to the value 256, which references this taco object. To avoid confusion, I didn't put the memory addresses here, but you can just assume that this taco is at memory address 256, and we can access the information, the name, location, and price given this one taco. Now we go inside, and we have to make sure that we don't have a full array. If we look at tacos.length minus 1, so in other words, 4 minus 1 is index 3. Index 3 is null. This is false. So we skip over that, and we move on to the for loop. Now we declare and initialize the int I to be 0, and then we check if tacos at index 0, in other words, right there, is equal to null. It is equal to null. It's the first element. Then what we do is assign tacos at index 0 to the value that is stored inside of a taco, which again is a memory address. This assigns tacos at index 0 to the memory address 256, and the way that you could think about it is this element of this array points to this object. And now you can see the parameter a taco references the same object as tacos at index 0. This didn't make a copy of this taco, it's just referring to the same one in memory. Now we go to break and immediately halt the loop. Notice that once we're outside of the loop, that index I no longer exists. The scope of a variable only exists where it was declared. Now, if we also notice, when we exit out of this method, a taco, that parameter, disappears. Parameters only exist inside the method it was declared in. But we have not lost that object. because tacos at index 0 is still referencing the object that was constructed in memory. Now let's add another taco. Let's start right here. Let's just assume again a taco was constructed outside of this method, which means that a taco references its contents, which this time we're assuming is at memory address 326, which is right here. Now I didn't put the rest of the information right here because I simply ran out of room. Now, going into the for loop, we first declare and initialize the index I to 0. From there, if tacos at index 0 is equal to null, well, 256 is not null. This object exists. So then we have to move on and update I to 1. Now, if tacos at index 1 is equal to null, and it is, so this is the first null element, assign that to the memory address. And the way you could think of this is it references that as well. We break, go outside the loop, which removes the integer I, and then outside the method, we lose that reference to a taco, but the array still references the objects in the memory. Going back to the code, now let's develop the code to remove a taco. Public void remove taco. Now this time we are not going to use the object taco. What we're going to do is use a property of the taco, its name, string a name. Just like before, we're going to assume this element here is not null. One element that we have to consider is we may not have a taco in this array with this name. So what we're going to start out with is first the int remove index, and we're going to assign that to -1. Whenever we find a taco that matches this name, then we're going to reassign the remove index here and then start that shifting process. But if we do not find a taco that has this name, then this is going to remain -1. As we know, negative values are incorrect values for arrays. If this is still a negative value or a purposefully incorrect value, this will tell us that we did not find it. Now, let's first search for the element that we're trying to remove. For int I is equal to 0, I is less than tacos.length I++. Now inside the for loop, if tacos at index I, now we recognize an array of objects are an array of memory addresses. So in fact, this could be null. One of the first checks you should do is whether or not that object exists before you ever call a method from it. So if tacos at index I is not equal to null, and tacos at index I, now this is the array of tacos. This is one instance of a taco, which means we can use all the methods that we have defined inside of this class. We are comparing the name, which we need to use the accessor to get the name. So back inside of here, we call .getName. Now, if this name dot equals a name, this means the object had been constructed and this name matches that name. If all of that is true, then we're going to set the remove index equals to I and then immediately break. Now, once we are outside of that loop, if the remove index is still equal to -1, this means we did not find the element to remove. In this case, we're going to return because we can't remove anything. However, if that was not the case, what we're going to do is shift everything over. So starting for int I is equal to the remove index. This is the element that we're trying to remove. I is less than tacos.length -1, we'll see why in a minute, I++. inside of this for loop, we're going to take tacos at index I and assign it to its neighbor, tacos at index I plus 1. Now, because we are using this I plus 1, we have to bound it by subtracting 1 from here. This is just like in bubble sort. Now, after we've shifted everything over, we need to make sure that that last element is still null. So tacos at index tacos.length minus 1, and we're going to just assign this one to null. Now, this is how we can remove an element from the array. Let's take a closer look at this. So using our previous example, let's take a look at this. If we were to call the method remove taco and the name was ASDF, then we first start out by simply going inside of here and assigning the remove index to -1. Now we have to search for the taco with the name ASDF. Going inside the for loop, we have to declare and initialize int I equals to 0 because we want to start with the first element. Then inside of here, if tacos at I is not null, as we can see, index I is at 0. Tacos at index 0 is 256. This is not null, so this is true. So now we have to check. Tacos at index I, so index 0, dot get name. We follow this reference over here and we get this taco's name, which is none. None is not equal to ASDF. So that is false, and so we have to move on. Increase I by 1, now I is 1. If tacos at index I is not equal to null, tacos at index 1 is 326. This is not null, so that is true. Now, tacos at index I dot get name. So I'm going to follow the reference down here, and I'm going to get this name ASDF. This does match this ASDF. So that's true and that's true, which means we have to then assign the remove index to the value of 1. That is the index that we're going to remove. We break out of the loop. Now, if the remove index is still equal to -1, the remove index is 1, 1 is not equal to -1, so we go to the else. Now inside the else, we go inside this for loop and declare I is equal to the remove index, which this time is 1. Now we shift all of the values over. So then we go over here and we assign tacos at index 1 equal to the value held in tacos at index 1 plus 1, in other words, tacos at index 2. Tacos at index 1 becomes null, which means we have now lost the reference to that object. Now we increase I by 1, which it becomes 2. Tacos at index 2 is equal to tacos at index 3, which is just assigning null to null. Now I is equal to 3. Tacos.length is 4. 4 minus 1 is 3, and 3 is not less than 3. We jump outside of this for loop and then assign the last index. Tacos.length 4 minus 1, 3 is equal to null, which is tacos at index 3 is assigned to null. Now when we're outside of the method, the parameter aName is removed. But not just that. We've lost the reference to this taco. We can no longer access this data. So Java being a memory managed language, its garbage collector will go along and find that there's no way to access this data. And so it will deallocate that information, thus removing the object. The next thing that we have to do is sort the tacos by the price. I'm not going to spend a lot of time on this because we're just going to simply use bubble sort to do it. So let's go ahead and implement this. Now this is how we can sort the tacos. Using bubble sort once again, we check each one of the side-by-side elements and sort that in ascending order. Now you may notice that there are some elements that were added to this. One of the first ones that we have to check is whether or not that next element is null. If the next element is null, we need to immediately stop this loop. However, if the next element is not null, then what we do is compare the element here, this taco, and its price, versus its neighbor, taco at index I plus 1, and its price. If we discover that this taco has a larger price than that taco, they're out of order, so we need to swap them, which happens right here. Pretty much the key element to keep in mind is when we are looking at objects, we do need to check if the memory address is not null. So in other words, does that object even exist? Once we do that, we have to look at the criteria that we're sorting it on. In this case, we're getting the prices from each taco in order to sort them. Now to not forget this element, inside of add I said to do sort. Let's not forget that, so I'm going to call this .sort tacos. The next thing that we're going to develop is we're going to write to a taco file. Let's go ahead and create this. Public void write taco file. String a name. In order to write to a file, I have strongly recommended to use the print writer. Now, writing to a file and reading from a file is fraught with all sorts of exceptions. So the first thing we're going to start with is our try and our catch block to handle any of those. I'm going to focus on just using the general exception E, and also inside of the catch, e.print stack trace. That way, if there is an exception, we can figure out where it happened. From there, we need to create the print writer. So we create print writer, file writer is equal to new print writer, new file output stream with the file name. Now that we've created this, all we have to do is use this similarly to system.out. Now there was a structure that we gave to the file, and we need to follow that. This file had two separated parts, the header and the body. Let's go ahead and write the header. So what we're going to do is use file writer.println, and then the first element was a literal taco amount, AMT, right there. This literal was then separated using the delimiter, the tab, and then after the delimiter, it gave the number of tacos that was in this file. So if we're printing out all of the elements inside of this tacos array, then what we need to do is say tacos.length to say the number of tacos that are found in this array is this much. And so now we've written the header. Let's worry about the body. Now for every element inside this array of tacos, we need to print out its name, the delimiter, the location, the delimiter, and then the price end line. In this case, I'm going to do something a little different. Instead of just a for loop, I'm going to create what's called a for each loop. So, for each taco in tacos. What a for each loop does is it establishes this temporary variable, and then for every single element that's found inside of this collection, it temporarily stores it one at a time. This is a shorthand for a very common for loop, and in fact, you could just use a for loop to do the same thing. Now, a for each loop is not great if you have to add and remove elements from the structure. It's only really useful to iterate through all of the elements of a structure. Now, if we discover that this variable here, this temporary variable taco, is equal to null, that means we encountered the first null element we need to break. Everything after this point is also going to be null, so we need to stop writing to the file. But if that's not true, then we take the file writer.println and we take taco.getName plus the delimiter to separate it, plus taco.getLocation plus the delimiter plus taco.getPrice. And now this follows the format that we established earlier, where the body has the name of the taco, tab, the location, tab, and the price, inline. Now outside of the for loop, and most importantly, we have opened up this stream. That way we can stream this data to this file. Now, since we've opened the stream, we must also close it. FileWriter.close. And so this is a way that we can write these kinds of files. We first group together the data into header information and the body. We also separate that information using a delimiter, the tab, and also endlines. Now, let's read from this taco file. Public void read taco file string a name. Now, once again, reading and writing, we need to put that inside of a try and a catch block. And we're just going to use the general exception E here, and also make sure that we call e.print stack trace. That way we can find an error in case one occurs. I have highly recommended to use the scanner to scan a file, and here's how. Scanner, file scanner, is equal to new scanner, new file, a name. Now the next thing that we're going to do is first we're going to read the header. The way that we're going to approach this is the exact same way that we're going to approach reading the body. Now, as this is a tab delimited file, what we're going to do is read it line by line. We're going to first read a line. We are then going to split the line based on the delimiter. We are then going to evaluate if that is formatted correctly. We're going to check the line, and then if it is correct, we then apply or process whatever we need to. For the header, what we need this for is to construct the array. And in order to construct the array, we need to know the size. So we need to extract the size from the header. String file line is equal to file scanner.next line. Now we know this method reads everything up until the end line. So starting from the beginning of the file to the first end line, this all gets stored into the file line. This is essentially reading an entire row. Now we need to break the row up into the columns. We create a string array, and then what we call this split lines is equal to file line, the string, dot split, using the delimiter. Split is a very interesting method that strings have, and we're going to be using this a good bit to read from these files. Let's take a closer look at what this method does. So first of all, the split method for a string separates the string into an array of strings given some sort of delimiter. The way this works is it starts from the first index, index 0, and then goes all the way up until that first delimiter. That's going to be in the first index that's returned back. Then from that first delimiter to the next one, that's index 1. From the second delimiter to the next one, index 2, 3, 4, etc., until we're at the very end. Now the method expects a regular expression to be passed inside of it. We're not going to go into discussion about what a regular expression is, but the way that you can use this for right now is if you have a delimiter, this is what's going to be used to split apart a string. Now, if we have this example up here, let's just say assume that this str that we're calling the method from is equal to this string, name1 tab, location1 tab 1. and we're going to split based on this tab. What happens is an array is constructed based on the number of times that this character appears. So since this appears twice, we know we have 1, 2, 3 fields, so this array is of size 3. Starting from the beginning of the string up until the first tab, this string is separated and then added to index 0. Going from that tab up until the next one, we get this information that is added to index 1. And then finally, the last tab to the end line adds that to index 2. Now do keep in mind that this is a double value, but this is inside of a string. So this indicates this is an array of strings, so this 1.0 is a string for now. We'll have to convert that later. But either way, when you call split on a string and you pass in a delimiter, it separates the information into an array, just like this. Now going back to the code, what we can do then is if splitlines.length. We need to verify if we have the correct number of fields. The header had 2. It had the literal, which said taco amount, followed by an actual amount. So if the length is equal to header field amount, then what we can do is get the size. Int size is equal to integer dot parse int split lines at index 1. First thing, split lines is an array of strings. We have to convert this string, which is holding the size, into an integer value by using the wrapper class integer followed by the method parseInt. This converts a string into an integer. Now what we need to do, we're reading this taco file, that way we can set the array to these values. So what I'm going to do after it has been read, we are going to recall init with this size. This effectively clears out all of the information that may have been held in that array before and reinitializes it using the size found inside of this file. Now, after that if statement, if that wasn't true, return. The header was ill-formatted, so there's not much else we can do. So the next thing is we need to read the body. We have to read the information about every single taco, construct an object with that information, and add it to our array. Here we go. While file scanner.hasNextLine. We're doing next line because we know that every row is separated by an end line. We also recognize when we are reading a file, it reads left to right, then top to bottom. So the next thing we do in this while loop is we read the line, split the line, check the line, and process. File line. We're just going to go ahead and reuse this variable. File line is equal to filescanner.nextLine. Read everything up until the end line. Split lines is equal to fileline.split based on our delimiter. Separate the row into the column information. If splitlines.length is equal to the body field amount, and as it was name, location, and price, it should be equal to 3. If that is true, then what we're going to do is then extract out the information. String name is found at split line at index 0. Starting from the beginning of the string up until the first tab, that's considered the name. String location is equal to split lines at index 1. After the first tab and up until the next one, that's the column for locations. If I could spell it right. There we go. And finally, double price is equal to double.parseDouble split lines at index 2. Now again, split lines is an array of strings. This is a string which we need to convert into a double and then assign it to the price. Now what we're going to do is construct a new taco. A taco is equal to new taco, and we're going to use the parameterized constructor. That way we can both construct the object while also setting its properties, name, location, and price. Now that we have constructed that taco, we need to add it to our array. And luckily, we've already developed a method that does that. This .add taco, a taco. Outside of this while loop, we need to close the stream. File scanner.close. And this is how we can read a tab delimited file, separate out all of the information, and then apply that into usable information in our program. The final thing that we need to develop inside the taco manager is a method that prints all the tacos out. Public void print tacos. I'm going to use a for each loop again, that way you can see it a second time. So in this case, for each taco in tacos. If this temp taco is equal to null, we need to break. Otherwise, we need to system.out.println taco. Now the subtle thing about this is when we're printing this, what happens in Java is it calls the toString method. So when we print each one of those, every one of the tacos is going to print out name with its name, location with its location, and price with its price. So now we've fully developed everything in the taco manager. We've taken care of all of the back-end work. Now what we need to do is add functionality so a user can use this back end. Let's go ahead and create the Taco Manager front end. And we're going to include the main method. Now we're just going to assume that the user input is going to come from the console, which means we need to import java.util.scanner. That way we can use the type scanner. Now from there, what we're going to do is create some static properties. The first one is going to be the keyboard scanner, tying it to system.in. The reason why we're defining it here instead of the main method is we want the scanner to be used across any other methods that we develop. Doing it in this way means we can call this from static methods without any issue. Now similarly, there is one taco manager that we're using, and we're going to go ahead and set that up in a similar way. We're going to create a static taco manager and then construct it using the default values. So this is going to create a taco manager whose array is of size 10. The next thing I'm going to do is greet the user. And just to show this off a little bit, what I'm going to do is instead of just a system.out.println, I'm going to separate that into a separate action. What I'm going to do is just create a public static void print greeting with a simple system.out.println, welcome to the taco manager. And then from there, I'm just going to initially call that inside of my main method. Now, as this method is static and this method is static, I can directly call this. So after that, I'm going to create a Boolean quit, and I'm going to set it to false. And while not quit, while we haven't quit the program. Now I need to prompt the user again, giving the number of choices or what they can do to use this program. Now, just like printing the greeting, printing the choices feels like a separate action, so I'm going to separate that into a different method. In this case, public static void print choices, and we just have the system.out line here where you enter 1 to add, 2 to remove, 3 to read a taco file, 4 to write a taco file, and 9 to quit. Now that I have that, all I need to do is inside the while loop is print the choices. That way the user knows what to do. Then we're going to int choice equals to keyboard.nextInt. Now because this keyboard is static, we can use this inside of the static method. To change this up a little bit, what I'm going to use is a switch statement on the choice. Now this easily could be an if, else if, and else, but just to show something different, I'm going to use a switch statement. Now a switch statement is broken into cases, like for instance case 1, in this case it is adding a taco. I'm not going to add the functional code to that quite yet, I'm going to get to that in a minute. But for right now, I'm going to break and I'm going to write all the rest of the cases. Case 2, break, case 3, case 3, break, case 4, break, case 9, break, and finally default, which acts like the else, will be system.out.println invalid input. So in other words, if the user enters a choice that's not 1, 2, 3, 4, or 9, that's invalid, and we just keep going. Case 1 was adding a taco. Now that is a separate action, and I'm going to separate that into a different method. It's a good idea to recognize the verbs because the verbs are the methods. Those are the actions. Adding a taco is an action. Instead of writing all the functional code inside of here, I'm going to separate that into a method. Now all we have here is another static method that first prompts the user for the name of the taco, then the location, then finally the price, and then we call the taco manager .add taco, and we construct a new instance of a taco given the name, the location, and the price that we've gathered from the console. Now all I have to do to use this is scroll up and then call the method. Let's do the same thing for remove. Scrolling down here, we create a static method remove taco, which asks for the name of the taco to be removed. We get the name, and then we call from the taco manager the method remove taco, providing this name. To finish this up, we just add the call to the method here. Next, we need to be able to read from a taco database file. Scrolling down here, we create another static method. That way we can just call it from the main method. We prompt the user for the name of the file. We store that information, and then we call from our object taco manager the method read taco file, passing in the file name. Now we just have to call this from our main method. Next, we need to write to a taco file. Scrolling down, we create another static method, write to taco file. We ask for the file name, then we get the file name, and we call write taco file right there. We're almost done. Scrolling back up here, if the user entered 9, this indicated that they wanted to quit the program. So all we're going to do is assign the value quit to true. Now outside of the switch statement, but still inside that while loop, I'm going to go ahead and call taco manager dot print tacos. That way, the user is first greeted. The user is then given the choices in how to use this program. All the choices correspond to an action, which I almost forgot to write taco file here. But now all of them have an action. And then finally, after that action has occurred, we just print the tacos that are currently held inside of that taco array. One more quick thing. After keyboard.nextInt, we're going to call keyboard.nextLine. In this way, we can avoid any unintentional bugs. Now that we have all of this, let's go ahead and try it out. Let's try to add a taco. Now I have to enter the name of the taco. I'm just going to say ASDF. And location of the taco, location 1. And the price, let's say 2. And now it's printed out the name, location, and the price of this taco. Let's add another one. Let's do ASDF2, location 2, and let's make this one 1. Aha! And now you can see when we printed this out, it sorted it by the price. Okay, let's try to remove a taco. Let's remove ASDF. And as you can see, the only one left is ASDF2. Let's add it back. ASDF, location 1, and 2. And now we've added that information back. Let's write this to a taco database file. And we'll just call it tacos.txt. Now let's restart this program and see if we can read in that information. Restarting the program, I'm going to read this file, which was tacos.txt. And as you can see, it read the information from this file and populated the array with it. This has been a long example that has gone over everything that we've discussed so far. Procedural programming, how to organize code into methods into classes to then create objects of those classes, and also how we can use exceptions along with file I/O in order to store more long-term information. Along with that, we have now established that we are organizing our data into a data structure, and the first one that we use is an array. But arrays are not perfect. And we're going to explore that next time and introduce a brand new data structure. With all of that being said, I'll see you next time.